Hey kiddos, so today we're going to be talking about evaluating functions. Now, evaluating functions is not a new skill, it's just the way that we look at the problem is different from what we've seen in the past. So last semester we talked about evaluating expressions where we took letters out, we took variables out, and we replaced those variables with certain values. That's essentially what we're doing today. Again, we're just using function notation, which is what we discussed earlier in the lecture. And function notation is where you have like f of x, where f is the function, that's the structure of what we're going to do, and the x is the value that we're plugging into that function. So let's look at our first example. Okay. Here we have the function f of x equals 3x minus 2. So here, 3x minus 2, this is going to be the structure that we're working within. So for each example, we're going to keep the 3x minus 2 part, but we're going to take the variable of x out and we're going to replace that with the value inside the parentheses. So when it says f of 3, what that means is we're going to keep the structure. So we keep the 3. I'm leaving a blank spot for x. We're going to keep the minus 2. And then instead of x, we're replacing that value with 3. That's what it means, f of 3. Same function, but instead of x, we're replacing it with 3. So that goes right there. So notice right away that the structure is the same. It's still 3 times a value minus 2, just like it was in the original function. And now we're just going to multiply it. 3 times 3 gives us 9, minus 2 from that, and that gives us a value of 7. So what this means is that when you're evaluating the function 3x minus 2 using a value of 3, what results is 7. Okay, so when I plug 3 into the function, 7 is the result, input, output. Okay, for number 2, same thing. We're going to keep the same structure, so I keep the 3. I'm going to leave a blank parentheses instead of x, keep the minus 2. And then inside the parentheses, I'm now evaluating using the value of negative 2. So 3 times negative 2 gives me negative 6. The negative 2 comes down, and negative 6 and negative 2 make negative 8. So super straightforward. When you evaluate a function, all you do is keep the structure of the original function, and you are evaluating it by plugging in different values. Okay, let's look at our next example here. Just make things a little bit more difficult by adding in a fraction there, but this fraction is super simple. It's just 1/2 or negative 1/2. Okay, so looking at the first problem, again, we're keeping the structure the same. So we're keeping negative 1/2. Okay. I like to put in that blank parentheses instead of x plus 4. Now, I like to do this just to make sure I understand what it means to evaluate a function. So I write down the structure first, then I go back in and I plug in the value I'm supposed to. So instead of x, we're replacing that value with 6. Okay. So negative 1/2 times 6 is negative 3. And then we're going to bring down the plus 4. Negative 3 plus 4 just gives us positive 1. Okay, now let's repeat. Again, keep the structure. This time we're replacing x with negative 4. So again, blank parentheses, plus 4 comes down, same exact structure that I normally have. But here I'm replacing x with negative 4. Okay, so the negative and the negative are going to cancel out. 1/2 of 4 is going to give me 2. That plus 4 comes down, and 2 plus 4 is going to give us a value of 6. So when I evaluate this function, negative 1/2 x plus 4, using negative 4, the output is 6. To make it a little bit more complicated, here we're going to evaluate a quadratic. So here we have 2 x values that we're going to replace because we have x squared plus 2x and then minus 1. But in this problem, we're going to use the same value for both x's. So even though there's 2 x's that are getting replaced, we use the same value for each x. So let's again keep the structure. So I have blank parentheses squared plus 2, and then blank parentheses minus 1. So every time I see an x, I'm going to leave that x out and put a blank spot instead. And now in those blank spots, I put the number 2. So 2 goes here, 2 goes here. Okay. 2 squared gives me 4. 2 times 2 is going to give me 4 again, minus 1. 4 plus 4 is 8. Take away 1 from that, and that gives me 7. Okay. Second part of this, again, same structure. We're just going to repeat that process. So I have blank squared plus 2 times blank minus 1. In the blank spots, I'm going to put in my value of negative 5, which is what I'm evaluating with. Negative 5 goes right there. That doesn't look like a negative 5. There you go. And negative 5 goes right there. And now we really have to think about what it means to square something so we don't get confused here. Negative 5 squared means negative 5 multiplied by itself. So negative 5 times negative 5. When I multiply a negative by a negative, it turns to a positive. And 5 times 5 is 25, so that's positive 25. 2 times negative 5 is negative 10. And then I subtract 1 from all of that. So I have 25 minus 10, that gives me 15, minus 1 more, that gives me 14. Okay. So again, when I evaluate a quadratic, nothing really changes in terms of how I approach the problem. It's just I'm replacing 2 x values instead of 1. Okay. Now we have our last problem. This one's a little bit more complicated because we're not replacing x with one value anymore, so our answer is not going to be a single value. Okay, we're replacing x with a binomial, meaning that x is going to be part of the final answer. Okay, so we have 5x plus 10, again, that's our structure. Oh, negative 5x plus 10. Good thing I went back and looked at that. Negative 5x plus 10, that's going to be our structure, so we're going to write that out. We have negative 5 instead of x, big parentheses, that's our blank spot, plus 10. Now, inside this parentheses, I'm going to put the whole value that I see inside the parentheses here, so 2x plus 3. Now, this is very similar to what we've done in the past, which is distribution. You have a number on the outside, and then you have a binomial on the inside, so we're going to distribute across both of those terms, and that plus 10 just kind of tags along until we get to it. So negative 5 times 2x is negative 10x. Negative 5 times positive 3 is negative 15. And now that positive 10 just comes down, and we're going to combine like terms to get the final answer. So I have negative 10x, and negative 15 plus 10 is going to give me negative 5, and that is our final answer. So again, because x is part of what we're plugging in, what we're evaluating with, then x is going to be part of the final solution. Okay. Last one, same thing. I'm going to keep the structure of negative 5, big parentheses here, plus 10. Inside that parentheses, I'm plugging in the entire value of this function, which is negative 4x minus 5. Negative 4x minus 5. Again, whenever I have a number on the outside and then 2 things on the inside, I'm going to distribute. So negative 5 times negative 4, the negatives cancel out. That gives us positive 20x. I switched back to red, my bad. Okay. Negative 5 times negative 5 is going to cancel out again. That gives us positive 25. And then the positive 10 comes down. Let me switch back to blue, keep it uniform. Okay. Now I combine my terms. 25 and the 10 can combine, so our final answer is 20x. And then 25 plus 10 gives us 35. And that's our final answer. Okay? So when you evaluate a function, really all it means is you're taking the x out of the original structure and you're replacing it with some other item. It could be another function, it could be a value, it could be a smiley face. Whatever you're replacing the function with in your f of x notation, you just evaluate it with that.